Twinkle, twinkle, little star, biggest puzzle from afar. How unlike the other ones, brighter than a billion suns. Twinkle, twinkle, little star, how I wonder what you are.
Hello, ladies and gentlemen from all corners of the universe. Today's podcast is a little different from the other ones. It's about something that is far, far away, many light years from here. It's a star spectroscopy.
That's right, Mina. We will be answering the question to the song. What you are... So, the twinkling stars that we see in the night sky, what exactly are they made of? Well, to start, a star is a luminous ball of gas, mostly hydrogen and helium, held together by its own gravity. Nuclear fusion reactions in its core support the star against gravity and produce photons and heat, as well as small amounts of heavier elements such as iron, oxygen, and carbon. Now that we know what the star is made of, let's refer back to the title of the song. How do stars even twinkle? Well, the answer is the distortion of light waves. As light from a star travels towards the Earth, it can easily move in a straight line. But once it starts traveling through the Earth's atmosphere, it gets bounced around in different directions by the particles in the air. That's why we see the dots in the sky glow so brightly.
Now that you've mentioned it, light waves can be understood as a spectrum. A spectrum is a band of colors as seen in a rainbow, produced by separation of the components of light by their different degrees of refraction according to their wavelengths. Basically, if you've ever shined light through a prism and seen the rainbow of colors that comes out the other end, then you've seen a spectrum.
That's true, but Mina, I thought the stars that only have one color. You know, when you look into the sky and all the stars appear to be white.
Actually, the color of a star depends on its surface temperature. Our sun's surface temperature is about 6,000 Kelvin, and when viewed outside of our atmosphere, it appears white. It's a common misconception that the sun is yellow or orange or even red. However, the sun is essentially all colors mixed together, which appears to our eyes as white.
You see, scientists were wondering how stars have different colors. After many research and studies, they found out that light can be perceived in different shades of color based on the wavelength. And that wavelength can change based on the star's temperature. For you to visually see it, it seems that stars with cooler temperatures, such as Aldebaran, found in Taurus constellation, has energy that is radiated in red tones of the electromagnetic color spectrum, while those with hotter temperatures, such as Rigel, found in the Orion constellation, have energy that is radiated in blue and white tones of the electromagnetic color spectrum.
That's right. Next time when you're out stargazing, you know that all stars have different colors and brightness. But it's not only stars. Other celestial objects twinkle and emit light waves. We can understand this thanks to the study of astronomical spectroscopy.
That's right, Mina. A spectrum can reveal many properties of either a star, planet, nebula, or galaxy. They reveal important characteristics such as chemical composition, temperature, density, mass, distance, luminosity, and relative motion using the Doppler shift measurements. Astronomers use the patterns of the lines observed in stellar spectra to sort stars into spectral class, because a star's temperature determines which absorption lines are present in the spectrum. These spectral classes are measured of its surface temperature. There are 7 standard spectral classes, from hottest to coldest. These 7 spectral classes are designated type O, B, A, F, G, K, and M. Recently, astronomers have added 3 additional classes for even cooler celestial objects, such as L, T, and Y. Pretty fascinating, right, Mina?
Oh yeah, that really is fascinating.
Yeah, that's right. Spectroscopy helps us determine the compositions of the temperature, density, and motion of celestial objects found in our universe. Not only is it important for astronomers, but for all the stargazers out there. Thank you for listening to our podcast. We hope you enjoyed it, and don't forget to look up and get lost in the wonders of the universe.